So this video will look at how we can perform basic commands in Unix to look at what files are present. The previous one looked at how we can transfer files, and now you should be able to log on to have this environment on the server. So we'll look at key commands. If you just press enter, you'll see that you have your username at the first part, then an @ and then login1 is the node that you're connected to on the cluster. Then there's a colon, then a tilde to indicate you're in the home directory, and then a $sign to indicate that this is the place where you should write in text. If you switch to something like C shell, you'd find that the setup is slightly different, so that uses a %sign, but we don't want C shell. We're just going to exit that. So if you're moving around Unix, one of those most important commands is pwd, which stands for present working directory, or where on earth am I, because it's easy to get lost. So you can see the directory set up even there, that there's an initial folder called mount. This contains Lustre, and then we've RDS live, and then my folder Downing. If we want to change directory, we type the command cd, but cd on its own doesn't actually do anything. There's no parameter afterwards to tell us what to do. Your current directory is called dot, so cd dot will indicate your current directory. Cd dot dot is the directory before. So if you do cd dot dot here, we move down to RDS live. So you can see RDS live, that's our new current directory. So we're no longer in home, and that's denoted at the start. So we still just start typing in at the cursor. So a handy way of going back to the directory you were at before is just cd and a dash or minus sign, like that. Press enter, and we're back in our home directory. A handy way of getting to our home directory, so if let's say I'll do cd dot dot then / dot dot, so now I'm in Lustre. Cd tilde also brings me back to my home directory. So if in doubt, I can always go back home and won't have the issue of feeling a bit lost, which can happen from time to time. If you go back to Lustre, what you'll see is that the server is set up with an RDS archive, ephemeral, and live folders, and the HPC part as well. If we go to RDS live, you'll see that there's a bunch of other people, and we're going to list the files and folders that are present. You can see there's a bunch of other people there present as well. So I'm going to go into my folder because I can't go into anyone else's. And then I can also do ls to see what's there. I happen to have a lot of things here. So many different things, and I can list them, and you can see it's alphabetically listing them. However, it's alphabetically listing them going along this column there with numbers at the start. You can also see that there's uppercase and lowercase used here. I can also list alphabetically, which is the default, like that. And that includes hidden files. So let's just -a list hidden files. The most convenient hidden file here is bash history if you're looking for old commands that you typed in, or you can just type in history. And you'll see all your commands there. If you press enter, you'll see a bunch of ones that look like this. So another listing command is to list with details, which is -l. So you can see here what I have now is the permissions, my own name, which I'm the one who owns the file and has access to this particular folder. And this is the size of the file, and this is when it was last edited or moved to this particular location. You can see that this one for Anaconda 3 is older. It's from May 10th, and it's much bigger. You can see the file size there. You can also see that it ends differently because it's a different file type. If you look further down. There's other files that are .text. And you can see when it was edited and the file size. I can see the ones that we transferred earlier, like test.sh and test2.sh. And we're going to look at those further. Another handy ls command is ls-lt, which lists them by time. So if we try that, we can see where ls-lt that these are the most recent ones, and we can go back in time and see ones that are older, all the way down here. We can combine ls-lta together and list them, including the hidden files. And you can see that there we have more files listed here, including the Google Authenticator, which was updated, and things like the bash history. When you log in, it will just record that you're logging in, for example. So those are the key ones. And what we can do is use the command mkdir to make a directory. So I might call this, I tend to call my directories, I put them all in capitals. And for example, new 123 might be a new directory you want to make. Just press enter and nothing happens. So what's gone on here? If I want to know that was new 123 actually made or not, I can just do ls and just type in that directory name, new 123. Again, nothing happens. So a better way of looking at this is to that's ls-lt new 123 to see what's inside. So now it's listing the contents of that directory. And you see there's nothing in there. So let's change directory cd and go inside new 123 and see what's there. So you can see I moved from home into that directory new 123. If I do ls-lt, it says there's nothing there, and there isn't. We haven't put anything there yet. So we can go back cd ... back to our home, pwd to check, and then what we're going to do is list a particular file type. So we're interested in those ones, sh. So what we can do if we're listing file types is list and use an asterisk as matching any particular character or series of characters or numbers, basically anything. So we had a file test.sh before, so we can list that particular file or even list the details like that. And we can remove the test part and put an asterisk to list all the ones that end in sh. So you can see there's a few there. These ones in the folder, and then one called miniconda and one called anaconda. If, for example, I want to just list the ones beginning with T and then anything and then ending in .h, I just put T at the start, then the asterisk. And then you'll find you just get test2.sh and test.sh. What we can do is learn about moving files next. So I can move mv a file from a destination to a location. So I have to specify where I'm moving the file. If I type in move test.sh and then do nothing afterwards, the computer will do nothing. It will give me an error message. It will say it's missing an operand, a destination after test.sh. We can even look for help if we look in move --help. So what we want to do is give a destination. And if we give a destination of a folder like this new 123, it will transfer the file into that folder. It will not copy it as being that name because it knows that news 123 is a folder already. So we can do that. And note that test.h will leave the home folder and move to the new folder, and there'll be no leftover copy in the home folder. So let's do that. And they're going to list tests.sh here. It says no such file directory. So let's go into new 123 and do ls-lt And there we see test.sh is there. We can even look at it with the command more, just to check that everything is okay, and it appears to be fine. We can copy that file if we want as well. So CP means copy, and the structure is the same. We have a source and a destination. It's the same structure for all of them, source, destination. Your source, the source is the original file, test.sh, and let's say we're going to move it to our home directory. So there's a few ways of doing this. The most easy way of moving it is just to use a tilde, like that. And tilde signifies our home directory. So we can do that without anything else, and it will copy that. Copy test.sh, which we showed was missing before, back to the home directory. So let's try that. cd ... to go down to the home directory. pwd, I'm in my home directory. ls test.sh. I see it's there. So it's copied over. So we can see that copy preserves, so let's go back and, so copy should preserve the original copy. cd minus, go back to new 123, ls-lt, and you can see at test.sh is still there. So we have two copies of it now. So it's good to know what the commands move and also copy. Those are two key ones, mv and cp. If I'm in my home directory, I want to remove test.sh, I can use the command rm to do that, but always be careful that you are not removing it completely, or that you may need it in the future, because if you remove it, it is very difficult to recover that on the cluster, and there's no recycling bin as such. So rm removes that file, ls-lt will show that it's actually gone completely. So be careful with that command, because once it's gone, it's completely gone. My own strategy for dealing with that is to use a folder mkdir old files, do I have one? Old files. And if I have a file that I'm not likely to use in the near future, but I probably will want to delete later once I'm happy with everything, I just will move that file test.sh2 to old files, and then I'll go to old files maybe in a few months' time and delete any large files from there. So I tend not to delete files that may be important, like script files that are small. If I want, I go into old files, and then I can copy test2.sh, and I can go to copy it back to my home directory, and then forward into new 123. And what I'm going to do here, rather than typing it in, is use the tab key in your top left of the keyboard, 2 keys below escape, and that will complete the file folder ending for me. Another way of doing the exact same thing, rather than this command with a ... going back to the home directory and then to new 123, would be to type it all out. So mnte cluster ords live downing new 123. That's the same thing. So the tilde is just a shortcut. Sorry, the ... is just a shortcut. And then the final one that we could also use is a tilde new 123. And we copy it over. Then we do the same thing, cd, and we can reuse this bit of code if we're lazy at typing. So Control C to copy, cd, and then Shift insert to paste. Now we're back in new 123, ls-lt to list the contents, and you can see that test.2.sh has been copied over. So that means we now have a better understanding of how to move files around. And you can also see the files and folders. If we go back, cd ... and / back like that, we can predict that we're going to move 2 folders from new 123 to ords live. So if you do that, you can see that that's the place where we are. CD minus to go back there, and then CD dot dot, that will bring us back to our home directory. So it's good practice to get used to moving between different folders, and then also moving or copying those SH files, which you can copy over again if something goes amiss, will be very good practice for you. So those are the main important commands. Other ones you can try from the files themselves. Another thing that you may want to do is to change the permissions using the command chmod. So chmod is a command simply to change the functions of different files. So what you can see here is this is read, write for the first two entries, and then read for the final entry. So at present, these files cannot be executed, but I might want someone else to be able to look at this particular file, like test.sh. The simplest way of making something available for other people in all forms is just chmod 777 test.sh, like that. And what's that done is that it's made that file read, write, and read, write, and executable by anyone. So anyone who's on the cluster can do whatever they want to that file, and normally that's fine. And that's also important here because we want to make this sh file executable. Another command, if we just want read access, is ch744, and that will mean that people are able to read your file. So if we do that there, we can see now that this file is now, sorry, see, 744 is for execution. You can see that this has been changed. And if you go back to the lecture slides, there's a brief overview of how you can toggle through different permissions depending what you want to do. And the reason for changing these permissions in the case of these files is simply that we want to make them executable because they are scripts that do something. So there's other commands that you can apply in the labs that we'll look at and that are on the slides, like man ls is a command to find out from the manual man more about the information command ls. ls stands for list. So we'll see that, and it will give you lots of information about ls and all the different things that it does. And you can just press enter to scroll through, or spacebar to go down a page. So you can see we had L list using a long format, and whereas T time or T source by time. And then we press Q to quit, like that. So the other key thing is to look at what programs are in your path. So echo is a command that will give you information on a particular variable. The variables are denoted by the $sign. So your path is the programs that are accessible to you without having to give their full location. So if you echo $path, it might get you, it might be a shorter list than this, but these are tools that are executable from your location. That's handy to know if you want to add on particular applications. Most applications have been installed already, and if you type in the initial few letters, you'll normally find that they're actually present already, such as move or copy and so on. So another thing is to look at files. So with these files in this folder, there's many ways to look at a file. One of them is more. We can do more and test.sh like that. Press enter, and it will show you what's inside that file. So it's a simple 4-line file. Another way of doing that is less test.test2.sh, and it will give you what's in the file, but it will present it on a new screen. And you just press Q to quit. So less is another one. I prefer more myself. Cat is another one. test.sh. It's nearly the same thing, although cat can also concatenate. We can also use the command head to look at the first part of a file. However, here the file is very short already, so we can do test head -n and 2 to indicate that we just want to look at 2 lines only. So that's now showing only 2 lines. We can change that to, yeah, I'm using the cursor keys on your keyboard to go up and down through commands. Again, because I'm lazy. Head -n3, we see 3 lines. Similarly, there's a command tail. Tail -n3 gives the last 3 lines. So you can see there, it's gone from echo hello name to echo echo, and we've got the same down there. If you do tail and 6, even though it's just a 5-line script, it'll just give all 5. If you do tail and just 1, it'll just give the last line only. These can be combined as well if you have large files for particular reasons. Another command is to symbolic link. So that can be convenient if you have a large file somewhere. So for example, I can do ln -s to symbolically link, and I might go back to a file in the directory below my home directory, and there's a short script called while loop, and I can symbolically link that to the current directory, and the current directory is signified by a dot. So you can see here, I have ln, the command, dash with a space, -s, I could have many spaces here, space, dot, go back to the previous directory. This is the file I want. I can have many spaces here if I want. It doesn't make a difference, just as long as I have one. And then a dot at the end. And that dot is really, really important as the destination, because I want to symbolically link it here. So that's done. List to check. And there we see it's symbolically linked. So there's an arrow pointing to it in the previous folder. So symbolic links can also be useful when you're for certain situations. So those are the main commands that we have to look through. And these commands will make your life easier. So for example, in the slides, there's ones like fastq_dump. If you're trying to get download files from the SRA, there's also ones like wget, which can download files from websites and so on. So these make things very easy for you. Another one that is useful is called grep. Grep is a pattern matching command. So put things in quotes to match a pattern. So for example, I might grep the word echo in test.sh. And this will produce all the lines that contain echo. So let me check the file more test.sh. You can see there, it's given back the 2 corresponding lines with echo present. If I want, I can also do this and instead change the search term to be val, like that. So that gives the all 4 lines contain the word val, or I can change it to a symbol like an equal sign, but I have to put it in quotes, or else you may get errors in certain situations. And you can see that it's giving the 2 lines with that equal sign, and we can do the same for test2.sh, but has no nothing with an equal sign in this particular case. Another convenient part of grep is that it can count the number of lines with features. So -c will count the number of lines with that particular pattern present. So you can see there's 2 in this particular situation. If we change that back to val, it gives 4. if we want to check the number of lines that are starting with the letter G, sorry, with the letter E, we can use the circumflex symbol, then E, to denote that. So you can see there's 2 lines that start with that, and in test.2.sh you can see there's actually 4. Another handy command, like our pattern matching option. So if we look at test.sh and grep it for val, we find all the lines have that, and in test.sh we find none have that. So let's try an equals sign. We have there we go. 2 lines matching. So V means we want to find the lines without the pattern. So if we do that, we will find the ones without this particular pattern. If we change the query to be echo, in this case, we'll find the 2 lines without that pattern present. And the final part of this part is that if we want exact matches, so let's say we want to grep with the W parameter, we can grep an exact match of the words ECH in test.sh, for example, to find that exact match. So if we look for echo, we find that we have an exact match for that exact word, whereas even though we have the pattern ECH in there, it's not an exact match. So if we're looking for an exact match, maybe it's you're querying a particular amino acid sequence inside a file, and that will retrieve it more efficiently. We can also combine these commands and send this output to a new file. So I'm going to call this new.text, and this greater than symbol says that we're sending this to a new this file. So we're piping it out, and then we can check to see what's present. We have our file new.text, more new.text to see what's inside. I can see that we have those 2 lines there. We can also append, so that's add to the end of a file using 2 greater than symbols. So this will append it to the end of that. Let's do it twice to see what appears at the end. And you see it's actually added the same pair of lines onto it twice again. So you have this that now in our file. So that's a way you can actually combine a grep and actually send it to a file if you have something that's maybe a large pattern match. And then a final point for this part is that we can combine files together. So if we wanted, we could actually concatenate cat test2 and test into a new file, and we're going to call it test.both.sh like that. So let's check that it works. You see the file there, test.both.sh, and it's combined the 2 files together like that. So you can see test2 was first, and then test.sh is after that. So that combines our introduction to key Unix commands.